Hello, and welcome to another episode of EnVisioneering Exchange, the podcast where industry leaders discuss the most important topics in sustainability, climate change, buildings, and urban efficiency. I'm Vic Marinich, Global Marketing Director for Danfoss, and I'm delighted to be the host of this podcast. You can subscribe to our show on Apple Podcasts, Spotify, SoundCloud, or wherever you get your podcasts. Today we have Joe Halliday from Danfoss Drives here to talk about current challenges and solutions in water and wastewater pumping. Joe is Director of North America Water and Wastewater Sales at Danfoss Drives. Joe, thanks for taking the time to join the show.
Thanks for having me, Vic. It's good to be here.
Can you tell us a little bit about your background and how you came to work in the water and wastewater pumping industry?
I've been in industrial automation process control for about 30 years after about 9 years in the military. And I was approached one day in 2010 as an opportunity to be a drives guy in the municipal water business in the Northeast. So I joined Danfoss in 2010 as a regional sales manager in the water wastewater sector. I've been doing that pretty much ever since. In 2021, I took over as a VP or leader of the water group here.
So today we're going to be discussing some of the current challenges affecting the water and wastewater pumping industry and some of the latest technologies that the plants and the municipalities are using to address those challenges. So maybe to start with an overall view, Joe, can you describe what those challenges are and how you see them differently from what the industry was facing 10 or 20 years ago?
Yeah, that's a great question and a really good open-ended discussion point. So when you talk about challenges over the past, let's say 20 years, number one, there's obviously the energy stuff, right? So we need to find different ways to save energy. Number two, there's resources. So everybody's doing more with less. 10, 15 years ago, a lot of municipal water plants or wastewater plants would have a staff of 10 or 15 electrical people to do the work, right? To maintain the systems. And they don't have those today, right? So they're cut down to less than 3 or 4 per plant. So you got to do more with less. And then there's quality. 20 years ago, maybe 30 years ago, people wouldn't want to be in the same room when you turned on a drive because quality was a little iffy, right? We were just learning some features of electric motor controls, speed controls, and things like that. So you had some varying degrees of performance. You flash forward to today, and that quality is through the roof. If it doesn't work 10 years ago, it's probably not on the market anymore. And that becomes a bigger challenge for all the players because everybody's quality has gone up, right? Who builds a better mousetrap, so to speak? We are doing more with less. So you're trying to be more self-sufficient. You're trying to automate more. And when I say automate more, you're trying to make the drive do more things by itself for the customer. And the energy efficiency thing is still there. One of the things that we enjoy here in North America is, from a global reference, our energy costs are relatively low. If you look around the world, people are paying a lot more for electricity than we are in North America. So energy savings is still probably the top 2 requirements or desires. But if you look at it from a global standpoint, it's even worse around the world because energy is so costly.
You hit on that point of energy efficiency. We're hearing a lot, and on this podcast, we've talked to a lot of different experts on electrification of everything, getting away from fossil fuels, right? But one of the commodities I think that we're hearing more and more about is actually water itself, right? I mean, you don't think of it as a commodity. It's kind of ubiquitous, just like electricity flowing into the house, right? Everybody expects to turn the tap and have the water come on. But there's some studies saying by 2025, global water demand could be up to 50% more than it is at current levels. So how is this, let's call it looming water scarcity, affecting the industry today? And how can municipalities be ready for this increased demand for water?
Yeah, so it is a number one resource. To me, it's probably the most essential business in life, right? You cannot live without water. As we look at water scarcity, you can't control the rain either, right? We talk about droughts and things like that. So people need to look at water conservation, water usage, data centers, which is not really part of municipal wastewater treatment plants. But I was reading this morning that data centers use a quarter of a gallon of water for every 40 AI thought processes that happen. So even that is going to be a huge water impact, right? So municipalities are looking at different things. They're looking at reuse programs. So when we used to take water deliver it to your house, you use it, we collect it from your house, we treat it, we return it to the environment in a natural state. Either it's put back into the ocean, or it's put into a river or a lake, a reservoir, a stream, or just spread into fields. Now we're looking at ways to recycle that. So take that right out of a water treatment plant, clean water, and take that right into something else it can use it for. Many places are using we call non-potable water or non-drinkable water for campus irrigation things, fountain things, stuff like that. So there is a move to reclaim some of that instead of taking fresh drinking water or fresh water that we would use personal basis and just using it for fun for a fountain or something, right? So we're using reuse water that way. And that's actually a very, very big popular program to do the reuse water systems.
Funny but related side note, when I was going to university, I went to the Air Force Academy, and every morning they would have us running around the parade fields, right, for us to get us into shape there as 18-year-old college kids. And we start off with one lap, then two, then three, and so on. And it got towards the end of basic training. We were out there long enough that the sprinklers started kicking on, right? And it's hot and it's dry up there in Colorado Springs. And one day I remember somebody broke ranks out of our formation and sprinted into the sprinklers. And you kind of look at the one guy, we're one class, unity, and right, so we all break ranks and we all jump into the sprinklers, and everybody's kind of cooling off under the sprinklers, and wondering when we're going to get chewed out by the cadre, right? And they're not saying anything, and that kind of seemed weird because we were always getting chewed out by the cadre. Anyway, a few minutes later, they finally say, okay, guys, that's enough. Everybody get back into ranks and all that stuff. And we were kind of all excited, motivated, got back into ranks. And as we're standing there, then the guy leading the group asks, "Did you guys all have a good time?" And right, rah, cheering. And then he says, "Did you guys ever wonder why the parade field looks so green?" And we kind of all stood there and thought, no, I guess we never did wonder why. He said, yeah, so they water the grass with the effluent from the wastewater treatment plant to keep the parade grounds nice and green. And we had just spent, 5 hours showering in the effluent there. And I can tell you, every one of us that took off our PT uniforms, they would stand on their own. Oh, yeah. I could have cracked my shirt in half, I think, once it dried. So the reuse of water isn't something new. That was, 35 plus or so years ago. So it's been doing it a while, but certainly becoming a lot more popular. And as water gets more scarce, right, we're going to see, I guess, a lot more of that. Huh?
Yeah, you think of it as a natural resource, right? It is a commodity, so to speak. We just have to use it better, right? In better ways, instead of just taking the attitude that it's always there and there's an unlimited amount of supply.
Right.
The reuse concept's been around for a while. Some of the marketing folks in various parts of North America tried to have programs called toilet to tap, right, as a reuse thing, and that didn't go over so red hot. Southern California has started a reuse program, which they got rid of that other kind of marketing. There are some microbreweries, I think, in Colorado, right, that are taking plant effluent right into the headworks of the microbrewery, right? So they're making beer. And if you think about different technologies, not to get off the drive thing, because that's what we're kind of talking about, right, but the last thing they do to water before they send it on its way is they sanitize it. Right. And that's done with chlorine or ozone or ultraviolet. Right. So they're going to better levels, if you will, of sanitizations to ensure that the water is actually purified, clean, that sort of thing.
Right.
The other thing that's very, very popular when we talk about the percentage of usage of water is reverse osmosis. Right. That's something we haven't talked a lot about, but they're building more and more RO plants to desalinate, make fresh water out of salt water. Right?
Yeah. And that's something, I guess, the days of excess, I don't know, whenever you're in the 70s, 80s, right? I mean, we see reuse of water being more cognizant of the value of the water, not just flushing it into the sewers. And we do the same with heat, right? Or cooling, right? We're not just dumping hot air into the atmosphere, or not always, right? And trying not to, but how can we capture that heat and use it somewhere else? So I think that's kind of a trend we're seeing in a lot of different parts of the industry Danfoss plays in, is whether it's water, whether it's heat, energy, finding ways to capture the waste and reuse it and recycle it, and not just assume, right, we're going to have this infinite supply of electricity or heat or water. So it's nice to see, right, we've got kind of a common theme as we're working to protect the environment on how we're a little bit more efficient with the stuff that we're doing, right?
Right.
So clearly, right, we're seeing more and more demand for water, more and more demand around water. And one thing we know, if it's becoming more and more in demand, chances are you're also going to see more and more regulations, right? The government likes getting involved in these things. So we're seeing more and more federal regulations coming, right? I'm sure local municipal regulations as well. So to meet some of these federal regulations, a lot of the municipalities, they're instituting energy efficiency and emission standards, right? So according to the EPA, water and wastewater plants can account for 30 to 40% of total energy use by a municipal government. So it's a big deal. What are some newer technologies that can help lower those plants' energy use?
Yeah, so number one, right off the top, is the variable frequency drive. The laws of physics tell us that in an electric motor, if I reduce the speed of that motor by 20%, I reduce the energy required to run that motor by 50%. We've had numerous examples of municipalities who have cut their electric bill. There's a little town north of New York City called the Village of Florida, New York. And they had a very small 5 or 10 horsepower blower application. And they used to just run it constantly. They put a drive on it. And 6 months later, the power utility started paying them visits, thinking that somebody tampered with their electric meter because they reduced their energy use by so much.
Right.
That's huge. There's a great global story in Copenhagen, the city of Aarhus, Denmark. In Marselisborg is the wastewater treatment plant. I might have that backwards. It might be the city of Marselisborg, but they put a drive on every piece of rotating equipment. So anything that's moving, any pump, any motor has a drive on it. They did some different things with sludge handling. They did some different things with wastewater processing. Here in North America, we predominantly run our waste treatment plants based on dissolved oxygen levels. They decided to do it based on ammonia levels. That did some different things with nitrification and denitrification, phosphorus removal, and things of that nature. But what it allowed them to do was reduce the energy. They also put on an energy recovery system that burned the biogas from the digesters. So that biogas burning generated heat and electricity. So they used that to run the plant. They did so well, they ended up with a 30 to 50% excess level of electricity and said, ooh, we're going to sell this back to the city. So now it's not a wastewater treatment plant. It's a resource recovery facility. And those kind of things are huge. We're doing more and more of that type of application here in the United States as well. Hasn't caught on quite to that level, but it's gaining momentum. And we're doing a lot of great things with the Water Technology Alliance from the Danish government.
Yeah, that's perfectly in line with what we were just talking about, how use everything, right? Whether it's waste heat, generating electricity. And I imagine the utility rates in Denmark are probably a bit higher than here in the US, as you kind of touched on, right? So, but is it just that price, do you think, that's driving the move quicker in Europe and Denmark, or are there other things keeping it from coming on faster here in the US?
Probably price is the number one speed reducer, if you will, of adoption, because quite frankly, it doesn't cost that much. However, when you talk about energy efficiency, you can directly correlate that to CO2 reduction. Everybody wants CO2 reduction, right? You might say I'm paying 8 cents a kilowatt hour, which is not a lot globally, but you can also say that for every kilowatt hour of energy I save, I reduce my carbon footprint by anywhere between 0.8 and 1 pounds of carbon equivalent. So now you've got some meat on the bone, so to speak, and everybody wants to go CO2 neutral. There's more and more mandates. I see them on advertisements on television that so-and-so Honda is a big one that said we're going to be carbon neutral by 2050, I think, something like that. And the electric car industry is out, and all that CO2 reduction, again, is relatable to energy efficiency.
And I have to imagine at 30 to 40% of your total municipal bill, I haven't heard any municipalities asking for, tax increases, right? So regardless of how low the energy bill is, if you can reduce that 30 to 40%, by 10 or 20, whatever it is percent, and not have to go for tax increases or not have run deficits and that stuff, then no matter if it's super high rates from Europe or let's call it more reasonable rates here in the US, nobody's going to complain about having their tax dollars not spent on those kinds of things, right?
Right. Exactly.
Yeah, I guess it makes sense. It'll take a bit longer to catch on here because the savings aren't quite as high.
Yeah, the other thing that you see from energy, you mentioned that 30 to 40% reductions. The biggest energy consumer in waste treatment is the blower systems, aeration. So blower manufacturers are becoming more and more efficient by themselves, right? They're putting high-speed turbo blowers in and things of that nature, which use less energy, produce more air, diffuse the air in better ways in aeration tanks, right? Mixing tanks, things like that. So they're improving on the process as well, and that drives lower energy costs.
Another challenge that we get away from the actual the plants themselves, right, is, and we hear it in a lot of different ways here in the U.S., right, is the aging infrastructure. Right, everybody talks about roads and bridges, but water absolutely is up there. You talk Flint, Michigan, or Mississippi. Water and infrastructure has been in the news a good bit in the last few years. So in recent years, we've seen a lot of big increase in water main breaks, right, or pump failures, or sewer leaks, and all those kinds of things. So are there solutions some of these places, the water, wastewater plants can implement that are going to help improve the system performance and lower the chance for those big catastrophic incidents?
Yeah, there is. And leakage is a huge thing. From a drive standpoint, we try to pressurize water systems, and we typically have a water distribution network, so that brings water to your house. The water plant could be 15, 20 miles away, and it has a certain pressure requirement so that when I open my tap, I get a certain amount of water pressure at my sink. Usually, you have to have the pressure in the system artificially high so that your house has enough pressure because you're 15, 20 miles away from the source. So, one of the concepts they've done are pressure zones. So, you maintain a lower pressure throughout the system by running VFDs in that system. So, you might have several different water booster stations that run at a lower pressure and a lower energy use. That lower pressure corresponds to a much smaller flow rate from a leak. So if you have, I don't have the numbers on me, but if you have a 2 millimeter hole in a pipe and it's pressurized at 100 psi, it's going to leak at a given rate. If it's pressurized at 50 psi, it's going to be a significantly different leak rate. What we found, there's been a study several years ago by some consultants globally, and they found a 38% reduction in pressure in the system results in a 53% reduction in leaks. So again, we talk about the electrical side, 20% speed reduction, 50% energy savings. Here we have a 35%, 38% pressure reduction with a 53% leak reduction. So now you've got huge ways to start saving that. The other thing that we find out in some of the systems where they're aging or whatever is you get pump clogs. The pumps plug out, they clog because of the nature of the materials that we're pumping, right? Wastewater, sewage, right? So what historically has been the response is, well, you got to live with it. Right? We've got a team of guys that go out once a week or twice, 3 times a month, and they shut the pumps out, they take them out, they clean them out, they put them back together, and that sort of thing. That's a lot of man hours. It's safety and things like that as well, right? So what we've come up with in the past couple of years is a pump deragging feature. Danfoss calls it a deragging feature. Other manufacturers will call it a pump clean feature. And what it does is it allows you to run your pump in reverse and hopefully shut off or unplug itself. A lot of pump suppliers will come up with non-clogging pumps and things of that nature. And for the most part, they work relatively well. So that's an industry move as well. Ways to defeat clogged pump situations. We have solved that problem with the deragging feature. And we have seen customers that have gone from 1 to 2 outages a week to less than 1 or 2 outages a month. And that is a huge cost savings. That's a standard feature that we offer.
Is that deragging, is that done on a timer, or is it done on, I don't know, sensing, I don't know, pressure drop or flow rates, or how do we know when to do it?
That's a great question. So in the Danfoss drive, we have 5 or 6 different ways to trigger it. You can just have an input, a button, right? Hit the button, it goes into reverse. You program how long it goes backwards for, how fast it goes in reverse, that sort of thing. You can also program it on a calendar event. You can do it on a clock event, things like that. The interesting feature is you can program a power curve into the drive itself, where it says at low speed, I'm using this many kilowatts. This speed, I'm using this many kilowatts. So you know what? Here's my curve. That's normal. If I start drawing more power along that curve, that would be an indication that my impeller is not turning or the pump's not pumping like it should. Maybe I'll trigger a derag and see if it goes back to normal there.
Okay, so there's a couple different options depending on how it works.
It can be manually or fully automated. Yeah.
Wow, super interesting. So before we wrap up, and any last comments, any questions I didn't ask that you want to make sure we cover here today?
The industry is changing from what drives used to be, as we call them, a shaft turner, right? And there were a couple of different reasons to do that. When you start a motor, you have a high inrush current. With the drive, you reduce that. Right? You can get some hydraulic events called water hammer, where you start that pump and here comes a slug of water and it's moving at full speed through the piping system and it hits valves and it hits elbows and things. There's a lot of force in there. So with the drive, you can bring things up slowly and reduce that. That was kind of like, okay, that's good enough. Well, now we've gone to the point where we take the drive itself and we turn it into a sensor. We turn it into a smart drive, right? So what that means is it looks at various signals in the process. It looks at voltages, it looks at temperatures, it looks at currents, torques, speeds, all that kind of stuff. All those data points and vibrations and winding conditions of the motor. So the stator windings, we're monitoring those things. That's all resident right in the drive. And we said that information's there. Let's provide that to the customer so he can do something with it. So now we offer what we call condition-based monitoring. We can hook up a vibration sensor and monitor for vibrations. So if something gets out of alignment, if a pump starts to clog up, that would cause different vibrations, right? So we can trigger deragging or we can set off different alarms. We can monitor the winding conditions of the stator, which I mentioned before. If they start to wear out before they have a catastrophic failure, the drive itself will alert the operator, hey, I got a problem. Somebody come take a look at me, right? Before it's burnt up. The other thing it can do is what we call condition-based monitoring, where it looks at all the variables in that pumping system, and it says, this is my normal baseline. If I start operating outside of that normal baseline, there's a problem. I'm going to let somebody know, hey, something's not right, and I need to be looked at. So the drive becomes smart, and it can actually have an advanced level of automation in the system itself. That's been very attractive to a lot of the customers that we're talking to.
Some interesting points. I think this is a good place, at least for this episode. We leave it here for today. That's it for this episode of EnVisioneering Exchange. I'd like to thank my guest, Joe Halliday of Danfoss, for joining us.
Thanks, Vic. Pleasure to be here.
Don't forget to subscribe to EnVisioneering Exchange on Apple Podcasts, Spotify, SoundCloud, or wherever you listen to podcasts. And lastly, if you enjoyed this episode, don't forget to rate, review, and share it with your network. Thanks for listening, and talk to you next time.
This podcast is for information purposes only. The views, information, or opinions expressed during the EnVisioneering Exchange podcast series are solely those of the individuals involved and not necessarily represent those of Danfoss LLC and its employees. Danfoss LLC is not responsible and does not verify for accuracy any of the information contained in the podcast series available for listening on this site. This podcast series does not constitute professional advice or services. This podcast, including Danfoss LLC and the producers, disclaim responsibility from any possible adverse effects of information contained herein. Opinions of guests are their own, and Danfoss LLC in this podcast does not endorse or accept responsibility of statements made by guests. This podcast does not make any representations or warranties about the guest qualifications or credibility. Individuals on this podcast may have a direct or indirect financial interest in products or services referred to herein. This podcast is available for private, non-commercial use only. You may not edit, modify, or redistribute this podcast. The developers of the EnVisioneering Exchange podcast site assume no liability for any activities in connection with this podcast or for use of this podcast in connection with any other website, computer, or playing device.